Well, good afternoon. So we are going to work in 8.1 today, and 8.1 is inverse functions. So to understand inverse functions, what we first have to do is understand what our sine function is. So we have y is equal to sine of x, seen this before, and f of x is equal to sine of x, right? We can write it these two ways. This is the way we can write it as a function. This is the way that we can write it as an equation, but they're both the same thing. And so we know that when we're doing sine of x, remember going around the unit circle again? As a matter of fact, go ahead and pull the unit circle up here. And put it in here, put it over here, reduce it just a little bit, resize it, and then anchor it. So when we have this unit circle here, we know that using radian measure going around, that we can go from 0 to pi over 2 to pi to 3 pi over 2 and to 2 pi. And we know at 0 radians, our sine value is 0 there. So we fill that in. Then we go up to pi over 2. We know that our sine is 1. And then when we go down to pi, we know that our sine is 0. And then when we go to 3 pi over 2, our sine is -1. And then when we go back to 2 pi, our sine is 0 again. So if you remember correctly, this is what our sine wave kind of looked like, right? And you do realize that when we're looking at the sine equation, it is oscillates. So it keeps on going, and it keeps on going this way. Now, we know that this is a function, and how we know is a function is because of the vertical line test. So what can we say? We can sit there and say that when we draw a line down for any function, it can only hit the function in one place, and this does. So we know that it passes the vertical line test, but if we look at horizontal line test and draw any line through there, if it hits it more than once, then we know that it fails the horizontal line test. Okay, so now that we know that it not only it passes the vertical line test, but it fails the horizontal line test, we know that this function as it is not one-to-one, because a one-to-one function has two properties. One, we know that a one-to-one function has to pass the vertical line test, and it also has to pass the horizontal line test. So, pass the vertical line test, and it has to pass the horizontal line test. So how can we determine that this needs to be fixed? Because since it doesn't pass the horizontal line test, we need to do something here. So what we are going to do, and I'm going to erase this and rewrite it. So how can we figure it out so that it can be a one-to-one function? And so therefore it does have an inverse, because a one-to-one function always has an inverse. And so here's my, whoops, erase this again. little, little. So here's my function. So now, instead of this lovely up, down, erase this again. There we go. So my function goes like this. Right, so since it fails the horizontal line test, what I have to end up doing is I have to only restrict it. So I'm going to take this part away, and I'm also going to take this part away to right there. And I'm also going to take this part away and this part away, okay? And so what I have is, if this is what my function is, then it passes my horizontal line test, but it then also passes my vertical line test, okay? And as you can see, there's only just a little portion up here. Well, this value that we have graphed is between negative pi over 2 and pi over 2. So now that we know that we have to pass the vertical line test and pass the horizontal line test, let's take a look at sine and what we can do. Now, before we do that, though, I have to talk about what an inverse function looks like. So let's say that I have some function here. Let's say my function looks like this. Come up here, right? There's my function like this. Well, what happens is I have to, my function then will flip right over the y equals x axis. And so then my other function would mirror right over that, so it would look like this. Come up here, and then it would go like this, because it's got a mirror over that y equals x axis, okay? So same thing goes on with this, because if I have this sine function going along, and then if I take the inverse of it, instead of it going along the x-axis, then it's going to go along the y-axis. So, but it'll be restricted between pi over 2, negative pi over 2, and pi over 2. So here's my sine function right here in the red, right? We see what the sine function looks like, right? And then we see y is equal to x. There's that y is equal to x. And then our arcsine function, it goes right here. And as you can see, probably starts right there, our red, and goes to there, to that one. And this is then mirrored over that y equals x axis. So, and it would normally go on up, but remember, yeah, I have to only, it has to be restricted between negative pi over 2 and pi over 2. So since it's restricted between negative pi over 2 and pi over 2, here and here, then what I can do is then just, I only have that portion that I can actually use as my arcsine function. So that's how we have to think about it. By the way, does this Desmos, if you ever need anything graphed on Desmos, it's really great. You can graph anything on Desmos, Desmos. So that's how we do that. So I'm going to erase this for a second, and then I'm going to talk algebraically. This is graphically what's going on in here, okay? And it's good to understand why this is going on, but let's talk about algebraically. So we know that if we flip it over the xy axis, that our x's are going to swap and our y's are going to swap. So if I have something like y is equal to sine of x, and I swap those, then it's going to be x is equal to sine of y. But I need this y out of this angle here. I need to get y by itself. So that's why, let me go back now, okay? Keep that in mind that I've got to get this y out of here. So let's say we have sine of 30 degrees. So if we put that in our calculator, and so if I say 30 sine, that gives me 0.5 or 1/2, right? So sine of 30 degrees is 1/2. And if I sit here and I look at sine of 30 degrees, it is 1/2 right there, right? So I know that that's what it is, right? But what if instead it said this? Sine of x is 1/2. Well, if we didn't know, excuse me, if we didn't know that it was 30 degrees and we couldn't look off of our unit circle, what could we do? Well, just like I swap x and y here, I'm going to swap this x and y here. But when I do that, I'm going to sit there and say arc sine of 1/2 is equal to x. So if I take arc sine of 1/2 and throw it in my calculator, I might be able to figure out that it's a 30-degree angle. So that's what I'm going to do. So I'm going to clear this out. And I'm going to take um, 1 divided by 2. Of course, that gives me 0.5, right? And then it's in degree mode, so I'm going to hit the shift up here. And if you notice when I hit the shift, I have this arc sine here. So I'm going to hit arc sine of 0.5 or arc sine of 1/2. And what does it give me? It gives me 30 degrees. 30 degrees. So now I can sit here and say that x is equal to 30 degrees. Now, when we know what the values are going around the unit circle, a lot of times we don't need to, use the arc sine. But if we don't have a special angle going around 30, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and then 360, if I don't have that kind of angle, I would have to use the calculator to find out. So let's do a non-pretty, because I call these pretty angles, because we know what the values are for those angles. Let's say I have my sine of x is equal to, how about 3/5? If I throw this into my calculator, all I have to do is then just take arc sine of 3/5, and that then would be, when I do that, go back to my calculator, I have 3 divided by 5, gives me a value, and then I take arc sine, that gives me a 36.86-degree angle, right? So 36.36, I believe that's what it said. 36.86. So this is going to be a 36.9-degree angle, right? That's how we can do that. Okay, but now I know you're going to sit there and say, well, yes, but that 3/5 would not only be in the first quadrant, but sine is also positive in the second quadrant. So I have another angle over here, right? I could sit here and draw an angle, right? 36-degree angle here. All right, but I would have another angle right there that would also have this same length, right? And you're sitting there saying, okay, but which one do I know? How do I know this? Well, good question. So, they saw that. So, what I want to do is, when we look at this, remember I told you this Desmos calculator, it's between, we can only have in the inverse function between negative pi over 2 and pi over 2, because it's just between this value and this value right there that we can use this sine wave, and it would pass the vertical line test and the horizontal line test. So one of the things that we need to know here is that for sine of x, or sine of theta, right, our restriction, our arcsine, is always going to be between negative pi over 2 and pi over 2. Or I can sit there and say negative 90 degrees and positive 90 degrees. So anytime that I use arcsine, by the way, this is arcsine or inverse sine. So arcsine, or I could say inverse sine. It's always going to be restricted between that. So if I'm drawing my unit circle right here, it's going to be between negative pi over 2 and pi over 2, right? Because this is negative pi over 2 down here, and then this is positive pi over 2. So that's what goes on with that, okay? So when I throw that in my calculator, it's never going to give it to me in the second quadrant. It's always going to give it to me in the first quadrant. Why? Because sine is positive in the first quadrant and it's negative in the fourth quadrant, right? So if it's between these two, the sine value is either positive or it's negative. And so when I throw it in my calculator, it's either going to give it to me in the first quadrant if it's positive or in the fourth quadrant if it's negative. And later on in 8.2 and 8.3, we'll talk about what we can do to try to find angles in certain places, okay? But just understand that for now. For sine, if we have arcsine or inverse sine, it's restricted between negative pi over 2 and pi over 2, which is negative 90 degrees or 90 degrees, okay? Now, I want to talk about, and this was for our f of x is equal to sine of x. Well, my cosine, my f of x is equal to cosine of x. I could really think about this in the same way, right? Y is equal to cosine of x, right? And so if I wanted to figure this out, I swap my x and my y, so I have x is equal to cosine of y. And then if I want to resolve for this y, I'm going to say that arc cosine of x is equal to y. So y is equal to arc cosine of x. So it's the same thing. So I could sit there and say, oh, what if I had cosine of x is equal to square root of 2 over 2? Well, we know, looking on our unit circle, that square root of 2 over 2 is going to be a 45-degree angle. But now what I'm going to do is go back to my calculator, and I'm going to throw this value in. So I'm going to say, let's see, I'll put that down. So I say 2, take the square root of that, divided by 2. That's going to give me 0.707. I've told you that before. That square root of 2 over 2 is 0.707010678, blah, 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 on and on. So then what I could do here is I could sit here and say, okay, well, what I'm really going to do is then take arc cosine of square root of 2 over 2, and I know I should get back 45-degree angle, right? It's going to give me 45-degree angle because this is the value. This is the actual value of the length of my x value, or of that triangle that I draw. So this is the value. So I'm taking the arc cosine of that value, and it gives me an angle. So let's see if I do that. So that's my calculator. So I'm going to hit Shift, arc cosine, and what does it give me? It gives me that 45-degree angle here, right? So if I'm looking at cosine, and I'm going to get ready to erase some of this. If I look at cosine, this is what my cosine looks like. Sorry. So for my cosine, what's going on is, here's my cosine wave. Remember, it starts at 1, it goes to 0, it goes to -1, and then it goes back to 0, and then back to 1, right? That's my 2 pi going on right here, right? And so what happens at this pi over 2, right? This pi over 2, and this is, this is pi over 2 right here, and then it goes on. But so what's going to happen is I'm going to draw this y equals x axis here, and my restriction then is going to be from here to here. But when I do that, and my restriction is from here, right there, to right there, that's where my restriction is, right? And so when that flips over the line, this part goes right here, and then this part right here goes out this way. So here becomes then my arc cosine wave, right? But it's only between this value and this value, because then it flips. Instead of it being angles here, now the angle's there. So we can always think about it being between 0 and pi. 0 and pi. It's those two values that are getting flipped here and here. Okay? So 0 and pi, right? And for this red one, 0 and pi. So that's what my restriction then for my cosine is between 0 and pi. So I will erase all of this first. So this is what I got. F of x equals cosine of x, or y equals cosine of x. I know that I can say arc cosine of x, which we can write as arc cosine, or inverse sine. Yeah, sorry. Inverse cosine. Arc cosine, or inverse cosine. So when I do that, I know that my restriction is going to be between 0 and x and pi. So in other words, in my unit circle, when I have this, then I know that I am only restricted between my 0 radians and my pi radians. So from 0 to pi. And if you remember, cosine is positive in the first quadrant, but it's negative in the second quadrant. So when I throw it in my calculator, if I have a negative value, it's going to give me an angle in this quadrant. And if I have a positive value, it's going to give me an angle in this first quadrant, right? So that's how cosine works. And then we have the very last one in Desmos again, which I've already graphed, which is tan. And then, so the red is the tangent function, and blue is the arctan function, and then our y equals x-axis. Now, if you notice, the restriction on this, right, the restriction on this is pretty interesting too, because if you remember, our function only is restricted between pi over 2 and between this value right here, right? Oops, get right on it. So it's only between this value, this value right here, and this value right there. There's, if you remember correctly, there's an asymptote right there. And this value and this value, if you remember correctly, was negative pi over 2 and pi over 2. It's negative pi over 2 over here and pi over 2 over here. Now, since my whole function goes all the way down and all the way up, that's why this blue goes all the way to the left and all the way to the right. but it's still restricted by this asymptote right there and this asymptote right there, because if I go past that asymptote and try to draw a horizontal line, then it's going to hit it in more than one place. So I have to restrict it from negative pi over 2 to pi over 2. So it has the same restriction as sine does. So if I have my function, which is f of x is tan of x, or I could sit there and say that y is equal to tan of x. Then I can sit there and say that I have arctan of x, which is going to be arctan or inverse tan. Yeah. And so it's restricted between negative pi over 2 and pi over 2. And then once again, on here, then I'm going to be restricted between here and here. And why? Because tan is positive in first quadrant. As a matter of fact, all of our trig functions are positive in the first quadrant, and they're negative in the fourth quadrant. And so when I throw an arctan in there, it's either, if it's positive, it's going to give it to me in the first quadrant. If it's negative, it's going to give it to me an angle in the fourth quadrant. Okay, and usually in this quadrant here and in this quadrant here, when you're using the calculator, it gives it to you as a negative angle. Okay, when you are in cosine and it gives it to you, it's going to give it to you with an angle between 90 and 180 degrees. We'll talk about that in a later session. So that's how we can figure it out. And that's how we can use our arc sine, arc cosine, and arctan in our calculator, because I could just as easily sit there and say negative 1. And that's what I'm going to do. I'm going to say negative 1. And if I sit there and put arctan, I better get negative 45 degrees. And do I? Yep. What if I take, and I'm going to clear this, how about 3 square root divided by 2? So square root of 3 divided by 2. And then let's say I take arc cosine. Oop, that gives me a 30-degree angle. Why? Because in my 30-degree angle, right? My 30-degree angle right here, right? This is square root of 3 over 2. This is 1/2, right? Square root of 3 over 2 for this angle here is adjacent over hypotenuse. So hypotenuse is 1. So square root of 3 over 2, put that in for cosine, and it gives me a 30-degree angle. Okay? So now that you've kind of understood what's going on with our inverse sine, those are our restrictions for our inverse sine. Okay, one of the last things that I want to do before I end this video is I'm going to talk real briefly about something, and then we will expound on it in a future. So what we can do is sometimes you're going to see this. You're going to see y is equal to sine of arc sine of x. Okay, you're going to see a sign on the outside, a sign on the inside. Or you might see y is equal to arc sine of sine of x. You might see one of these two things. These are really composite functions. So I can sit there, and if I say, g of x is equal to sine of x, and h of x is equal to arc sine of x. If I have this, then I have y is equal to g of h of x, right? This is a composite function. Or if I have this, my y is going to be equal to h of g of x. So I've got this g of x in, and I'm tucking it in, this g of x in, tucking it in for this x here. So what can happen sometimes is I might have something like y is equal to sine of arc sine of, we'll say square root of 2 over 2. So square root of 2 over 2. So if I'm looking at this, square root of 2 over 2, it's positive, so that's going to be a 45-degree angle. And then if I say y is equal to the sine of a 45-degree angle, right? Then I know sine of 45-degree angle is just square root of 2 over 2. Now you're thinking, oh boy, this is redundant, or this is kind of silly. Well, yeah, but sometimes then we have other values that that we might want to look at that aren't so pretty, that we don't know what the actual values are. That and we'll talk about this in another um, session. So, and then over here we might have y is equal to arc sine of sine of, we'll say, pi over 3. Well, by the same token, I would have arc sine, a sine of pi over 3. So I would sit there and say arc sine of, and sine of pi over 3 is going to be square root of 2 over 2. But I know my arc sine is square root of 3 over 2. I apologize for that. Oops. Say that again. So sine of pi over 3 is going to be square root of 3 over 2. And then if I take my arc sine of square root of 3 over 2, I know that that's going to be in the first quadrant. So I get pi over 3 back out. I always tell my students in my face-to-face class, if I have a value in, this is a value. So I always say value in, I'm going to get a value out. So my answer will always be, if I have a value, they give me a value here. If I have a value that goes in it, I'm going to end up getting a value out. That's for these composite functions here. Here I have an angle right here. And so for this one, this is angle in. Then I'm going to get an angle back out. Now, these are really simple ones. Value in, value out, angle in, angle out. These are really simple ones. And in another video, we will talk more about this, where the values aren't going to necessarily always be the same. And we will talk about that in a little bit more detail. So that's it for 8.1. And I will talk with you when we get to 8.2.